Chilingarian disks in early type dwarf galaxies.
Hello everybody. I'm just going to present you some of the results. Some of the work I've been doing over the last few years. And you know, when I was asked by Anatoly and Olga, they said to me, we're interested in dwarf galaxies, but please don't call them dwarf ellipticals because the conference is about disks. So that's why I'm talking about disks in dwarf early type galaxies. Usually they are called ellipticals. They are not. And I will start from this historical perspective. This is Messier 31, Andromeda Galaxy. It's two satellites, NGC 205 and M32. And yet in 1944, it was pointed out by Bade that even though their luminosities are very similar, their spatial extent on the sky are very different. So the half-light radius of NGC 205 is 10 times that of M32, which means that the surface density is 100 times lower in this galaxy. Again, we should keep in mind that the luminosities are similar. And later it turned out that NGC 205 it's a prototype of a class of dwarf elliptical galaxies, or dwarf early type galaxies, which are the most common galaxy type in clusters and rich groups nearby in the local universe. And on the other hand, M32 became a prototypical CE, it's a compact elliptical galaxy, and it's a very rare object, and I'm not going to talk about them right now because they're out of the scope. So what do we know about dwarf early type galaxies? Well, they're dwarf and they're early type. They have a luminosity of fainter than -18 in B and smooth elliptical morphology. At least how they were classified initially based on, let's say, photographic images from Palomar survey. They have, compared to elliptical galaxies and bulges, which have simply concentrated profiles, dwarf ellipticals have nearly exponential brightness profiles, but here exponential actually doesn't mean disk, because when we all make interpretations about light profiles of dwarfs and giant galaxies, and we are talking about Sursich indices, we have to keep in mind that actually the Sursich model is purely empirical approximation. It is not physical. And it is, moreover, it's projected, so you don't know the extent on the z-axis, the extent of the object on the z-axis. So, here I can just point out that dwarf ellipticals have exponential brightness profiles, or profiles with low Sursich index, 2 and below. Normally they don't have interstellar medium and don't exhibit any ongoing star formation, with very little exceptions. In bright dwarf ellipticals, the fine structures have been detected, and I will talk about them later because it's actually the subject of my talk. Often their rotation is supported. If you plot the diagram of V over sigma versus ellipticity, many of them lay on the line corresponding to the rotationally supported spheroid. Some of them are even above, suggesting the disky nature, but some of them are below. But here we have to keep in mind that we don't know the exact orientation, since the galaxy usually doesn't have any spiral arms. Then you don't really know whether the axial ratio you measure on the sky, it's actually an axial ratio of three-axial ellipsoid, or it's a disk, or it is oblate spheroid. Dark matter fraction is quite low compared to giants. It's like 50%. In galaxies of this intermediate luminosity, like -16, -17, and the ages are intermediate and metallicities are subsolar. So, if we look at the diagram presenting absolute magnitude and effective radius versus mean surface brightness within this effective radius. Effective radius is half-light radius, including half of the galaxy light. We will see going from bright galaxies here to faintest galaxies like M32 here, and here, as fainter the galaxy is in terms of luminosity, as higher the mean surface brightness is. Whereas it's the opposite for dwarf ellipticals. For dwarf ellipticals, fainter galaxies exhibit fainter luminosities. It's also quite remarkable that most dwarf ellipticals have more or less the same size. So the effective radius of almost all dwarf ellipticals lays between 600 parsecs and 2 kiloparsecs.